Test the hypothesis using the classical approach and then the p-value approach. Be sure to verify the requirements of the test. So our null is that p is 0.2 and the alternative is that p is greater than 0.2 where n is equal to 125, x is 40, and alpha is 0.05. So our requirement here that we want to test to make sure is that n times p naught times 1 minus p naught is greater than or equal to 10. So in this case, 125 times 0.2 times 1 minus 0.2. So let's do that on our calculator. So 125 times 0.2 times 1 minus 0.2. So we get 20, which is greater than or equal to 10. So we're good to go. So the classical approach here, so again we can do one prop z test. So we're going to do stat, go to test, and then do one prop z test. So p naught is 0.2, x is 40, n is 125, and then this is going to be greater than, which is already selected, and then we're going to press calculate. So I'm going to go and write down the p-value as well. So remember, for the classical approach, we're concerned about our test statistic. So this is 3.35, or approximately equal to 3.35. And for the p-value, this is approximately equal to, so that E is in scientific notation, so this is 3.98 times 10 to the negative fourth, so this is 0.000398, so pretty small there. So remember that 10 to the negative fourth, we're going to move it to make it smaller. So anytime I have a negative exponent in scientific notation, my number should get smaller. Again, a p-value represents probability, and probability is between 0 and 1. So 3.98 doesn't make sense for a p-value, so remember that as you're working through this chapter. So I'm back to our classical approach. So we're working with greater than, so we have a right tail test, so our critical region's on the right. So we just have one critical value, z sub alpha here. And alpha is always the value of the critical region, or the area in the critical region here. So this is 0.05. So 1 minus 0.05 is 0.95. So we can determine the critical values. So just to show you guys, there's a little table with some of the predetermined critical values already on there. So let me pull that up and show you guys and see if that one's on there. So you can pull this up here. So you'll see our level of significance, and then left-tailed, right-tailed, two-tailed. So if we go back to our example here, our level of significance is 0.05, and we're dealing with a right-tailed test. So 0.05, right-tailed is 1.645. So we have that this is 1.645. We can test this in the calculator, so let's do that. So second bar is 3, and then 0.95, comma 0, comma 1, and there's that value of 1.645. So then we want to compare these two. So 3.35 is going to fall somewhere in here. So our test statistic falls in the critical region. So we know that we are going to reject. Okay. Our test. So we reject, so we know that C and A are not possibilities. And then notice it's comparing the test statistic to the critical value. Well, our test statistic is greater than our critical value. So our test statistic is greater than the critical value. So answer choice D here. So let's look at the p-value approach. So if we compare our p-value to alpha, so our p-value to alpha here, our p-value is pretty small, and it is possible here that you may type in 0.000 as a choice, as an answer there. In this case, that's probably what would happen. And alpha was 0.05, so the p-value is less than alpha, so we reject. So A and B are not possibilities, and we reject because the p-value is less than alpha. So make sure you know that if you do not know the condition, you're probably not going to make any higher than a 50 on your test. So please make sure you know the condition. So when the p-value is less than alpha, you reject the null hypothesis.